So let's continue this topic of points of concurrency and what they're used for. So how to make them and what they're used for. Last class we talked about the circumcenter. Today we're going to talk about the centroid. We'll still need the midpoint formula. We're going to use the distance formula today, but we're not going to use the slope-intercept form. But we do need some of these older formulas we've been using for a while. So remember, the circumcenter is the center of a circle where the vertices of the triangle are on the circle. So that vertex is on the circle, that vertex is on the circle, and that vertex is on the circle. And since this is the center, that means if I draw these three radii, they're all going to be the same length. So the circumcenter is equidistant to the angles of this very special triangle. Now the centroid is another point of concurrency, and it is the center of gravity. They both start with C, so it can be kind of confusing. So the centroid, we're going to talk about that again off the graph and on the graph. So grab a little note outline if you haven't already, or you can do this without one. But the centroid, our new point of concurrency, it's made up of something called medians. And so a median is another new vocabulary word. If you drive in the road, you have seen the median is the line that divides the road in half. Well, since a triangle isn't like a square, like or a rectangle like a road, it kind of like divides the triangle in half, if you want to think of it like that. So to create the median off the graph, what you do is you bisect one of the sides. So you're going to measure it and divide it by 2. So if it's like 10, then this is 5 in. And then you're going to connect that midpoint, that bisector point, to the opposite angle. And so kind of like this picture. And for each side of the triangle, remember there's a median on there. I can bisect each side of the triangle, and I can connect each of those bisector points to the opposite angle. So we have these three triangles. Again, we have an acute, obtuse, and a right, and obtuse. So grab your rulers or your protractors and measure, let's do this in centimeters, measure each side of the triangle and bisect it, and then connect it to the opposite angle. So again, measure each side of the triangle, bisect it, connect it to the opposite angle. Okay, so pause the video and let me have you actually do that. Okay, hopefully you have already done it and you're unpausing the video, or you've already taken the notes on it. And what you should realize about the centroid is that the centroid is always inside the triangle, unlike the circumcenter. So these red dots, they are all the centroid. They are all a point of concurrency of 3 special lines, segments, and those lines are called medians. Now, there's a math application of the centroid besides just being the center of gravity, and that is if you look at one median, I can't trace. If you look at one median, this red line I have here, then I can think of some formulas to go with it. So again, this right here, this dot is the centroid. And hopefully you notice that this segment is much smaller than this segment. So it doesn't cut the median in half, but it does have a certain relationship. If I know the whole median, this part from the centroid to the side of the triangle is 1/3 of the total median length. And if I know the segment from the side to the centroid, if I multiply it by 3, that's going to get me the median. So those are those two formulas. That's the same thing. If I know that this is 1/3, it's natural that this is 2/3. And if I know the smaller segment, if I double it, it'll get me the larger segment to the angle. So let's practice this concept. I think I should have 3 triangles on the bottom of your page. Okay, so for the first example, if DG equals 14, then what is GC and what is DC? Let's solve one problem at a time. So I'm going to look at DG, and DG is from here to here, and that is the segment from the centroid to the side. And GC, this segment right here, is from the centroid to the angle. So I'm going to look at my formulas that I just had down, and I'm looking for one that says to the side and to the angle. And there's two formulas. I'm going to pick this one. So to the side equals half of the measurement to the angle. Again, this 14 is to the side, so I'm going to plug in 14 on this side and just an x here because I don't know it. So now I have 14 equals 1/2 x. To solve this problem, we multiply both sides by 2, and I get that this length, this pink length, is 28. You could have used the other formula that involved side and angle, again plugging in the 14 for the to the side part, and you'll still get 28. So CG is 28. Now if I know CG is 28 and DG is 14, all together D to C, I add them and I get 42. Okay, let's try another example. If GC is 14, so G to C is 14, that's the segment from the centroid to the angle, then let's solve for DG right now. DG is from the centroid to the side. So I'm going to look for the formula again, centroid to the angle and centroid to the side. This is one of the formulas I gave you. The 14 is going to the angle, so I'm going to put the 14 on this side and x over here. And I have x equals 1/2 times 14. To solve this, you just actually take half of 14, so x equals 7. And it makes sense that this is the smaller one because, well, it's smaller than 14. Here's the other formula that had angle and side in it. It's the same thing. You get 7. So you choose which one you want to memorize. So DG is 7. Now I can find D to C by adding them together, and 7 plus 14 is 21. Okay, last example for off the graph. If DC, the whole length is 14, what is DG? So the purple thing is the median. The whole length is the median. The orange one that I have here from the centroid is to the side. So the formulas I have for the median to the side, there's two of them, and this is one of them. So to the side equals 1/3 to the median. I'm going to plug in the 14 for median because that's what it is. And so x equals 1/3 of 14, which is about 4.66666 or 4.67. Okay, so this is 4.67. If I want to find the other segment, you could subtract that from 14, and that'll get you to the angle, or you could use again one of the formulas, and you will get 9.33333. And you'll notice that they add again to 14. Okay, so let's flip it over, and on the back, pause the video, and let me maybe try doing this problem for a minute, and then unpause the video. Okay, so if CX is 8, oh, this is X right here. The centroid is X. So if CX is 8, that's to the angle. And I know that to the angle is twice as big as to the side. So this would be 4. I know they're not equal to each other, right? So the longer one is twice as big as the shorter one, where it's 2/3 of the total length. So then I know that XP is going to be 4. From C to P, I'm going to add them together. 8 plus 4 is 12. NB is on the side of the triangle. Remember, to make the centroid, it's created by medians. And a median is made by bisecting the side. It's hard to write. Bisecting the side, and then connecting it to the angle. So again, bisecting the side and then connecting to the angle. So since I had to bisect the side, well, that means if this is 5, this is going to be 5 right here. So NB is 5, which means the whole length is 5 plus 5. CB is 10. Okay, so pause the video and try this next one, and then unpause it when you're ready. Okay, it says, again, this is X. It says CM is 10. Well, we know automatically, again, the centroid is made by medians. And a median is created by bisecting the side and then connecting it to the opposite angle. So since I bisected the side, that means this is also 10 and this is 20. So MA is 10 and CA is 20. Okay, then it wants XB. XB is right here. That's the longer part. So if I know the shorter part, I double it to get the longer part. So XB is 8. And then altogether, 4 plus 8, MB is going to be 12. Okay, so pause the video and try this one, and then unpause it when you're ready. Okay, it says C to A is 10, and again, the centroid is made of medians. You're not writing this part every time, which is when you bisect the side, and then you connect to the angle. My handwriting is getting worse and worse. So since I bisected the side, this is 5 and this is 5. So MC is 5 and MA is 5. And then MX, remember X goes to the center, is what we want. And we know that the whole median is 8. So if the whole median is 8, remember the shorter segment is a third of the median, and that's to the side. And then the one to the angle, that one is going to be 2/3 of the median. That's to the angle. Oops, I don't know what just happened there. So let's see, 2/3 of 8 is 2.66666, so 2.67. And then, sorry, 1/3 of 8, what am I saying? 1/3 of 8. And then 2/3 of 8 would be 5.33333, so 5.33. Hopefully that makes some sense. At least you know they're not equal to each other, right? Okay, so tape that little note outline in, and then now let's just recap this really quick. How do we find centroid on a graph? So that was off a graph, so remember, now we're going to focus on a graph. So grab the little note outline. The centroid, again, it's our new point of concurrency. It's made of these new words, medians. On a graph, to make the median, well, we need to bisect it. So if we want to bisect it on the graph, we need to use the midpoint formula. And then we can connect it to the opposite angle. So we do need the midpoint formula. So how are you going to do this? Well, if I give you 3 points and I ask you to find the centroid, the first thing you need to do is plot them. And then we're going to show our work. We're going to calculate the midpoint of each side. So finding the midpoint of QR, pause the video, try finding the midpoint of QR. And then we will, so that's adding the 2 x values, divide by 2, add the 2 y values, divide by 2. And I get -2, 1. And then I'm going to plot -2, 1. And that should look like the midpoint on the graph. I'm going to label it M. Now I'm going to find the midpoint of QS. Pause the video and find the midpoint of QS. Okay, so add the 2 x values between Q and S, divide by 2, add the 2 y values from Q and S, divide by 2, you should have gotten 0, -3. When you plot 0, -3, that should look like the midpoint from Q to S. Let's label that N right now. I'm just picking a random letter I haven't used. Okay, and then we have another side, SR or RS. I used SR because that's my initials. And pause the video, find the midpoint from S to R, and then unpause it when you're ready. Okay. So you should have gotten to -1. Okay. Now, after we bisect it, we're not going to draw 90-degree angles. This isn't the circumcenter. We're going to connect it to the opposite angle. So when I connect it, I get this as my centroid. And it won't always be a pretty whole number. For y'all, I'm trying to make it a pretty whole number. And so that is the point 0, -1. Okay. So remember, we have some fun facts about the centroid, these fun facts. So I might ask you on the homework to prove one of these fun facts. And the way you prove it, I don't want you to just count the distances, especially if they're up or down or left or right. I want you to prove those distances by using the distance formula. So I might ask you to prove that the side is 1/3 of the median, so I'd ask you to find both of those distances to prove that. So tape in your other set of notes and then finish your Khan Academy, and there is also a worksheet for this.